session, but anyway, the same concept I've explained here is also going to apply on part C. So there's no problem. All right, so we move on to part C. All right, so part C says we have A union B, then we have intersection C. Then we've been told to verify that this is equal to A union B, then intersection A union C. So for the left-hand side, we have A union B, intersection C. So we start with what is in the brackets first. So what do we have in the brackets? So in the brackets, we have B intersection C. So B intersection C is simply just, it simply just means we find the elements that are common in B and C. We look at the elements that are common, the elements that are present in both B and C. So when you check set B and C, in B there we have 3, 4, and 6. And then in C we have 5, 6, 7, 8. So B intersection C is simply just a singleton set which contains 6 as a member. So a singleton set is a set that contains one element because it is only 6 which is common between B and C. So 6 is the only common element there. So B intersection C is simply just what? 6. And then we have to find the union set between B intersection C and A, according to the question. So A is given to be 1, 2, 3, 4. We have 1, 2, 3, 4. So we have to find the union set between this set and that set. So the union set between these two sets is simply just equal to, we combine the two sets. So we have 1, 2, 3, 4, and 6. So we have managed to find the left-hand side. So we also have to find the right-hand side. So how do we find the right-hand side? So the right-hand side is simply just the distributed version of the left-hand side. So they are trying, or they are asking us to verify the distributive law. So when the left-hand side is distributed, it gives the right-hand side. So the right-hand side there is equal to, we have A union B, then intersection A union C. So the first thing that we need to find is A union B. So A union B simply means that we have to combine set A and B, we put them together. So A union B is simply just, we combine set A and B. So in set A, we have 1, 2, 3, 4. And then set B, we have 3, 4, 6. So we put a 6 there. And then, so this is our A union B. So we have our A union B. If you want, you can even write it there, which is 1, 2, 3, 4, 6. And then we're finding the intersection of this set and this set. So we also find A union C. So A union C is simply just a combination of A and C. So in A we have 1, 2, 3, 4. And then in C we have 5, 6, 7, 8. So in C we have 5, 6, 7, 8. So the total, or the combination of these two sets, when you add them, you are going to have 1, 2, 3, 4, 5, 6, 7, 8. So this is what you're going to get as the result. So now we have our A union C. And so we have our A union C, which is 1, 2, 3, 4, 5, 6, 7, 8. Then to find the intersection set between this set and this set, we have to look for the common elements. So the common elements, we have 1, 2, 3, 4, 6. We have 1, 2, 3, 4, 6. So the common elements are 1, 2, 3, 4, and 6. So now to verify this, you have to check whether the left-hand side is equal to the right-hand side. So now how do you check that? You just check the numbers. So on the left-hand side, we have 1, 2, 3, 4, 6. Even on the right, we have 1, 2, 3, 4, 6. You can now say the left-hand side is equal to the right-hand side. Hence what? Verified. So hence verified. So this is what we have. So let us also verify the De Morgans on part E. So part E there says we have to verify that A union B complement is equal to what? A complement intersection B complement. So how do we verify that? So we first take the left-hand side as well. So the left-hand side is A intersection, A union B, then the complement is out, and the complement is outside. A union B complement. So this is the left-hand side. So how do we now take care of this, or how do we solve this? So we first have to deal with what is in the brackets. We first have to find A union B, and then we come and find the complement of the answer. So our A union B is simply just the combination of A and B. So in A we have 1, 2, 3, 4, and then in B we have 3, 4, 6. So our A union B is simply 1, 2, 3, 4, 6. And then we find the complement of A union B. So meaning we list the elements that are in the universal set, excluding those that are in A union B. So these elements are simply just these elements are simply just going to be in the universal set. We have 1, 2, 3, 4, and 6, meaning our A union B. I mean, in A union B we have 1, 2, 3, 4, 6, meaning in the complement we're going to have the remaining numbers which are in the universal set, which are 5, and then we have 7, 8. So this is the complement of the set. So let's quickly move on to the right-hand side. So the right-hand side, we have A complement intersection B complement. So for this one, we first have to find what? We first have to find A complement and also find B complement, and then we find the intersection of the two sets. So to find A complement, we are going to list the elements that are in the universal set, excluding those that are in A. So A is 1, 2, 3, 4, and the complement of A is simply just going to be 5, 6, 7, 8. So this is the complement of A that we have. Then the complement of B, so B is simply just 3, 4, 6. So the complement of B is simply just going to be 1, 2, then we have 3 in B, so we don't have to write it. Then we have 4, we don't have to write it. And then we have 5, then we have 6 in B, we shouldn't write it. Then we have 6, and then there's also 7, 8. So we have 7 and 8. So we have to find the intersection between A complement and B complement, meaning we look for the common elements between A complement and B complement. So the common elements, we have 5 there, we have 5, we have 7, we have 7, we have 8, we have 8 there. So now the right-hand side therefore becomes the common elements, which are 5, we have 7, and we have 8 there. So to confirm or to verify this, you have to check if this is equal to that. Now, since they are equal, you conclude by saying the right-hand side is equal to what? The left-hand side. Hence, verified.
I'm behind on how we were finding the complements.
The complements. Okay.
A complement and B complement. What was the concept again?
So for a complement, it means that you are listing the elements that are in the universal set, excluding those that are in A. So meaning you don't have to write the elements that are in A. So for instance, if you have, let me make this, let me draw a Venn diagram here to make it practical. So we have the universal set, which contains elements. So I'm going to write my A there. So we have the universal set, which contains elements. Okay, before I write the universal set, let me write A. So for A, we have 1, we have 2, we have 3, and 4. So these are the elements that we have for set A. And then the universal set in total is supposed to contain elements including what? 5, 6, 7, and 8. Yeah, so when you talk about a complement, we're simply talking about, when you talk about a complement, we're simply talking about the elements that are outside A. So the elements that are outside A are which elements? So where I've shaded, which elements do we have there? We have 5, we have 6, we have 7, 8, and yeah, just up to 8. So we have 5, 6, 7, 8. These are the elements that we listed there. So to what's this, to describe what a complement means, a complement is simply just listing the elements that are outside A, but those elements are supposed to be part of the universal set. That's what it means. The same applies to B. B again, you do the same. If at all just understanding it directly is difficult, you can be drawing a simple Venn diagram. So in the Venn diagram there, you have to first start by writing what? Your set B. So what elements do I have in B? I have 3, I have 4, and 6. So now in total, or the other elements that are remaining, which are in the universal set, the universal set there is simply just this set here, which we have been given. So the elements that are not in B, but in the universal set, they are there are what? So we have 1, we have 2, we have 5, then we have 7, we have 8. So now if we say we have to find B complement. So B complement, we're simply talking about elements that are outside set B. So these elements are what? We have 1, we have 2, we have 5, 7, and 8. So that's what it means. Have you gotten the concept?
Yes, I have. Thanks.
All right. So we proceed. Let's quickly do this one, which is part 4. So for part 4, we have A, which is equal to A, B, C, D, E. Then B is D, E, F, G. Then they're asking us to find A minus B intersection B minus A. So usually this is an empty set. But let us verify. Let us see if it's going to be an empty set. Okay. So we first have to find, okay, let me write the question. We have A minus B, and then intersection B minus A. So how do we solve this? So the first thing that we have to do is to find A minus B. And then the other thing we have to find is B minus A. And then we can find the intersection between the two sets. So for A minus B simply means that we have to list the elements that are in A, excluding the intersection set between A and B. So the elements that are in A are, so the elements that are in A are simply, the elements that are in A are simply A, B, C, D, E. This is A, but to list A minus B means that we have to remove from this set A that we have to, okay, let me not write it here because I might end up confusing someone. So let me write A here alone. So A is simply just A, B, C, D, E. So to find A minus B, we have to list A excluding the elements that are in B. So in B, what elements do we have in B which are also in A? So we have D. D is where? D is in both sets. In short, we look for the common elements. So let me write set B here. So set B is D, E, F, G. So the common elements between set A and B, we have D. So we remove D there. And then what else we have? We have E, we remove E. Oh, sorry. Okay, yeah, it's there. I thought it wasn't there in B. So we also get rid of what? E. So the remaining elements are the ones that are A minus B, are the ones that are giving us the solution for A minus B. So we have A, B, and what? And C. So in the word form or in description form, we can say A minus B simply means that we have to list the elements that are in B, excluding, we have to list the elements that are in A, excluding those that are in B, meaning you have to list A, excluding the intersection set between A and B. So this is what we have. So B minus A, we have to list B, excluding the elements that are in A. So we get back to the same two sets. So we have to list B, excluding the elements that are in A. So we look at the common elements. We have D there, we have D there, we have E there, we have E there. So the remaining elements in B are the ones that we are going to list here. So the remaining elements that we have F and what? And G. So we are trying to find the common elements between A minus B and B minus A because we have intersection in between there. So what this means is that we find the common elements between this set and that set. And if you look at the two sets, we don't have anything common. So A minus B. So what this means is that A minus B intersection B minus A is equal to what? An empty set, because we don't have anything common between this set and that set. Okay. So can we proceed to the next question? All right, so silence means yes. All right, so we move on.
So we can proceed, I'm sure.
Okay.